Do you feel there is something in quantum mechanics that just doesn't fit? I'm not talking about if it is weird or not. I'm talking about if it's incomplete, if there's something missing. Why should there be a principle of uncertainty just for the sake of it? If science is about knowing, and uncertainty is a limit to our knowledge, is it philosophically acceptable not to try to find a way to break through that principle? Or at least try to understand why it is there.
Like Einstein, I've never bought into that randomness without a reason, and that has led me to an idea. It's an idea about physics foundations, and while I think it makes a lot of sense, I scribble the handle its nature and to get to workable calculations. I'd say that what I want to present is a conjecture about the structure of reality. I've called it the fractal maze hypothesis, and I've arrived to it seeking three purposes.
1. To find the origin of quantum randomness. To tackle with a measurement problem without hidden variables and without intrinsic uncertainty. 2. Avoid the concepts of space and time, or at least try not to use them directly. 3. Seek for non-computable physics along the line of Penrose's ideas.
The premises are twofold.
The first one is this action principle still holds, but completely, as in classical mechanics, not at the sum of paths in Feynman's path integral formulation. Second one, the ultimate structure of reality is discrete, and space-time simply does not exist. But what do I mean by this? The evolution of any physical system is composed by events between its components. These components can be the particles we know, or perhaps something deeper that we still don't know. Anyhow, when and where an event happens comes from the interpretation of the observer of the underlying structure. And this structure comes ultimately from the very same network of events, which is in principle dimensionless.
The networks I run into are very similar to others explored by other approaches. Look, quantum gravity, causal sets, Wolfram physics, or quantum graphite. Even the nodes of this network could be related to concepts like 𝚃𝚎𝚌𝚗 amplitude. But what is a game changer here is to put on top of that a supreme quantity which must be optimized, and to take that to its last consequences.
An optimization rule applied on a truly discrete substrate, if taken seriously, will produce a non-local effect which will be limited in scope but very complex to encompass. No matter how the discretization is performed, or if it is coarse or refined, this subtle creature will sneak in and ruin our calculations by producing leaks in all digits. But all this, even if it seems, is not completely random. In fact, this effect is not part of classical mechanics only because space and time are assumed to be continuous.
As you get into the discretization, you lose all your long-trusted tools of differential calculus. Euler equations, together with the theorem of identity, cease to be valid, and uncertainty arises. But this uncertainty is not God-chosen or absolute. Its origin is in the principle and is deeply chaotic. I must admit that so far I couldn't get any practical use of this because any calculation turns rapidly into a godlike task. But if you could undertake calculation like this, you start from all the possible networks of events that can be built. And then each event contributes action with a certain value. So, the real network is the one that makes global action minimum. To understand how the basic mechanics of this thing work, imagine the following.
The starting point is that every time a measurement is made, and equally, every time a particle interacts with another particle, nature is faced with a choice. And, of course, nature always takes the best option, the one of the least action. Alright, assume an event, call it X, involving a binary choice between one, which confers from this event, an increment of action, deltas 1, and 2, which entails another, deltas 2. Let deltas 1 be less than deltas 2. In the first instance, the system should choose the lesser action deltas 1, but it is not so simple. The choice of deltas 1 or deltas 2 implies two different subsequent chains of events that propagate throughout the particle's environment. So, choosing option 1 implies a new subsequent choice, and this one is followed by another and another, falling in an endless series of choices. The same goes for option 2. The tree of possibilities is different for 1 and 2 and contains paths with different action values, which depends on all other events surrounding event X. Let this one be the best option. This is the lesser option 1 of all choices after choosing option 1, and let this other one be the best option in case of choosing 2. Both values are the smaller ones of all possibilities on their branch. I'm noting these values like this so that U stands for universe and OPT for optimal. Delta S might be smaller for option 1, but the system will take the best over option. And also, the task of finding the way of the action does not end here. Towards the past, the chain of events extends symmetrically through all the choices that made event X factual. Moreover, the count is not restricted to sequences of events including event X, since all events imply more than one partaker, be they particles or something else. Those which do not arrive to event X follow other routes. This means that surrounding events connected with our event become points from which other chain of events branch out, potentially draining or supplying action and influencing X through larger and larger, but in principle weaker and weaker loops. So, in this silly example, as in quantum field theory, the least action path is the most likely. But this doesn't mean it cannot be outperformed by the rest of the options. And now, you have a reason for the divergent outcomes. It's the influence of the rest of the universe. But to know what actually will happen, you'd have to compute the whole network of the rest of the chain of events. And there you have a problem, because you are part of that network of events, which is what makes this thing ultimately non-computable.
because you have to compute yourself, computing all the network, which also contains you. I know, you may think that the influence of a single event against the rest of the universe should be, well, negligible, nothing. But this depends on the range of fluctuation of action. Think that even for a single event, the values of S are in principle unbounded. The big problem is that the surrounding environment finally embraces and eats up the full history of the universe, what makes the phenomenon apparently intractable. But I still think there could be ways to corner it. A toy model using this idea for a spin can be checked in this link. It's very oversimplified, but you'll see that its behavior gives food for thought. When you approach this idea naively from a reduced model, you might consider discarding it. I also considered it, because it seems to allow to use the retrocausal mechanism to outsmart nature and take advantage of the evolution that, thanks to the principle, will know the system will have, and get, for example, to send faster than light messages or to influence the past. But if you take into account the interconnection that the observer action inevitably imply, and that any disturbance will produce past-future loops, then you realize that your actions are becoming like a dog chasing its tail, and it no longer seems easy to dilute the mechanism. Maybe your feeling is that this smells like supper determinism. And yeah, it's the same for me. But don't bet on it, because as you get deeper into the suitability issues, you may begin to spot loopholes that could potentially escape the rule itself. In any case, this is only an overview. I'm not stopping here. In addition to this video, I will continue to post many others and also to write more articles and explanations. But I'm doing this because I've realized that the first step to take was to communicate you concisely the essence of the idea. That for two reasons. The first one is that I know you all are smart people, which means you probably have important matters to deal with. So if I want you to stick around for the rest of my rambling, first I need to show you that there is something powerful behind it. The second one is that I'm going to need help. Help to start this rolling. Not only with the physics stuff, like maths, models, calculations, simulations, but also with science stuff. Like, I need to promote this. So communications, the social networks, videos, editing, all that. If this idea sounds good to you, subscribe to the channel and follow me. Also, if you'd like to participate, to discuss, or just chat, get in touch. Hope to see you soon.